Good morning, students. So I hope all of you understood the first 4 questions. So today here we have to discuss another one very interesting question. This one is question number 5. And if you see the question is given here in figure 6.20, D is parallel to OQ. 6.20 means actually the figure is this one. So now here D is parallel to OQ as well as DF is parallel to OR. And what we need to prove here, we need to prove EF parallel to QR. So that means at first if you see here DE is parallel to OQ. So in this case you see where is DE. So DE parallel to OQ first of all given, as well as here given DF parallel to OR. This one is also given. And what we need to prove, we need to prove here EF parallel to QR we need to prove. So if you see clearly, first condition, whatever given to us DE parallel to OQ. So if you see here the parallel line D is parallel to OQ, that means these two are parallel given. So in case of this one, if we consider the triangle POQ, now this one is a triangle here, and if this triangle we consider, then DE parallel to OQ if given, so easily we can apply here the Thales theorem, is not it? So in this case you see here POQ, this one is a triangle here, and in this triangle DE is parallel to OQ given, so easily we can apply here the Thales theorem. And with the help of Thales theorem, what we can write, the other two sides are in the same ratio, is not it? According to the Thales theorem, if two lines are parallel, that means this one is the third side, the other two sides are in the same ratio or divided, or we can write the other two sides are divided in the same ratio. This one is the Thales theorem. So if we apply here, so if we start the solution here, so first of all what you have to write, first we consider this triangle. Which triangle you have to consider? POQ. This one we consider because DE is parallel to OQ given to us. So that's why at first if we write in triangle, this one we write POQ, in triangle POQ, comma, and here we have to write DE parallel to OQ, which one is given, is not it? So this one is given to us. So in this way we have to write. So in triangle POQ, and if you draw the diagram separately here, the POQ. So that means if you see this one is POQ, P, here it is Q, and this point is O. And now in this case D is parallel to OQ. So that means this one is D and here it is E according to our diagram. So this part just we separately draw here POQ. So in this case if we separately draw, then this one is a triangle, and in this triangle D is parallel to OQ again. So we know by our Thales theorem. So that's why here we have to write therefore by Thales theorem, or you can say basic proportionality theorem also. By Thales theorem, what we can write here, by Thales theorem, the ratio of the other two sides, that means the other two sides are divided in the same ratio. Other two sides means the third side is this one, for this third side the opposite vertices is this one. So from here we have to write, what we have to write, PE by EQ. So according to the Thales theorem, what we have to write, PE by EQ is equal to, second one we write here, PD by DO. So this one we write here, PD by DO. I hope all of you understood this one. I repeat this one, PE by EQ is equal to PD by DO, and we put this one is equation number 1. Is it clear? So similarly another parallel lines are given here. These two are parallel, DF parallel to OR. If you see here DF parallel to OR, so DF is this one, OR is this one. So in this case easily we can consider the triangle POR, and the same process whatever we have done in the first one we have to apply the Thales theorem. So that's why in this case if you write here in triangle POR, so if you write down the triangle POR, and here given what, DF parallel to OR, DF parallel to OR given. So in bracket you have to write this one is given. Clear? And now here therefore by Thales theorem, so if you write down the Thales theorem, what we have to write here, so if you see the diagram separately, POR, if we draw the diagram separately here, the diagram is like in this way. So you see here this one is P, clear, and here this one is O, at this place R, and this one is a parallel line, and this parallel line is DF. So DF parallel to OR already given to us. So therefore by Thales theorem, what we can write? The third side is this one, the opposite vertices is P, so we start from P. That means the other two sides are divided in the same ratio according to our Thales theorem, because DF parallel to OR. So in this case what we write? PD by DO. So in this case we write PD by DO is equal to PF by FR. So that's why here we have to write this one is PF by FR. Is it clear? And we put this one is equation number 2. So now after writing these two, now if you see one similarity is here, PD by DO and PD by DO. In both equation 1 and equation 2, PD by DO is here. So if you compare, so PD by DO is here, PD by DO is here. So if we compare this equation 1 and equation 2, so easily we can write PE by EQ is equal to PF by FR we can write. Isn't it? If we compare these two. So that's why from here, after that you have to write from 1 and 2. So from 1 and 2. So that means if we compare these two, then easily we can write here PE by EQ is equal to PE by EQ is equal to PF by FR. So that's why here we have to write PF by FR. So now here, if you see this ratio PE by EQ, so where is PE by EQ? If you see the diagram here, PE by EQ as well as here PF by FR, that means which one is PF by FR? PF by FR. If we draw the diagram separately here now, one thing you see, this one is P, this one is Q, and here it is R. Clear? So now in this case, if we consider the line EF, so according to our equation 1 and 2, if we compare these two, then we get the result PE by EQ, PF by FR we get. So this type of ratio when we get in our converse of Thales theorem, what is the definition or statement of the converse of Thales theorem? If the ratio of the two sides, are equal, that means the lines are, in this case we can, what we can say? We can say parallel, isn't it? So that means in this case, if these two ratios or if these two are equal, the ratios of these two sides are equal. If you see PE by EQ is equal to PF by FR we get. So from here what we can say, according to our converse of Thales theorem here, what we can say? EF parallel to QR easily we can say. So that's why here finally we have to write, therefore we have to write converse. Now in this case we have to write by converse of Thales theorem. So in this case we have to write by converse of Thales theorem. What we can write, since the ratios are equal, so that's why the lines are parallel. So that's why we have to write here EF parallel to QR. Is it clear? What we need? We need EF parallel to QR, and this one we get here. Is it clear? The ratios are equal, so that's why by converse of Thales theorem, the lines are parallel. Lines are parallel means EF parallel to QR. So I hope all of you understood this question, does not it? So in our next class, we have to continue this exercise and we discuss question number 6. Is it clear? Okay.